Hi folks, we're going to take a look at page 369, number 15a, and we're going to look at the first inequality. So they're asking us to solve this inequality, so we see that a little different from what we've solved in the past. Here we've got exponential expressions here. So I think what I'm going to do is I'm going to do what I did to try to solve other inequalities. I'm going to take everything to the other side and let one side be equal to 0 and see if I can figure out when the left-hand side is, in this case here, positive. So let's go ahead and see. So here I've got 2 to the 3x minus 4 to the x plus 1 greater than 0. Okay, so if I think of this as a function, okay, now that I have this as being greater than 0, I just have to determine where this expression is positive. And let's keep in mind, where are the only places a function can change sign? Well, first of all, it can change sign at an x-intercept, okay, so when this is equal to 0, or it can change sign at a discontinuity. However, there's no x value for which this left-hand side is not defined. So there are no discontinuities. This thing is valid everywhere. So the only thing I have to do is determine where 2 to the 3x minus 4 to the x plus 1 is equal to 0. In other words, I have to determine where 2 to the 3x is equal to 4 to the x plus 1. And I'm left with solving a fairly easy exponential equation because I can put everything to the same base. So here this is 2 squared to the x plus 1, so I've got 2 to the 3x equals 2, and use the third exponent law, 2x plus 2. And here, since the bases are the same, the exponents must also be the same, so we have 3x is equal to 2x plus 2. So here let's solve, bring the x, so x is equal to 2. So this gives us the x-intercept for this expression. Looks like there's only one. So that's the only place that this expression can change sign. So now I'm going to make my number line. Okay, so I only have to check less than 2 and greater than 2. So I'll put in 0 here. So what do we have? If we put in 0, we have 2 to the 0 is 1, minus 4 to the 0 plus 1 is 1. So 2 to the 0, which is 1, minus 4 to the 1, which is 4. So it's negative. And now let's take something greater than 2. Let's put 3. So what do we have here? We have 2 to the 3x, so it's 2 to the 9, minus 4 to the 3 plus 1 is 4. Okay, so 2 to the 9. Let's see if we can do this without a calculator. So this is going to be 2 to the 6 is 64. So 128, 256, 512, minus 4 cubed is 64. So let's see, 64 times another 4 is 256. Okay, and so what do we have? That this is positive. So this means that in this whole interval from 2 to 2 to positive infinity, this expression has to be positive. Hence, the inequality is satisfied. So our answer here is x can be anything from 2, which we're not going to include because that's where it's going to be equal to 0, since I'm looking for strictly greater than. So it's going to be from 2 to positive infinity. Okay, so let's do a quick recap here. I'm faced with solving an inequality with expressions I'm not used to using. Well, again, start by trying to recycle an old method, and that method is to bring everything to one side and figure out where that expression can change sign. In this case here, there's no discontinuity, so the only place it can change sign is when it's equal to 0. Set up your number line and test your intervals. Okay, that's it for this one.